All right, welcome back. Now that we have our plugins figured out and our user components figured out, let's take a look at establishing that control over the video in the room. So, our next exercise is going to be add video control to the UCI. We're going to create a new layer on the UCI which displays the immersive IP address and the session key. The layer should only be visible when the displays layer is active and only when the immersive source is routed to at least one of the two displays. We're using control pins and logic blocks to configure each TV to automatically turn on when a laptop is connected and then automatically route that laptop to the displays. And last but not least, we're going to configure the TVs to turn off when there's no active source for 10 minutes. All right, there's a lot there, so let's take it piece by piece. We'll jump back into our schematic and let's head up here to our sources. The first one being laptop 1, the second one being laptop 2. Now we need to establish the ability to have the connections of those laptops turn on the TVs and have that connection automatically be routed to the displays. We're going to get that from within this HDMI AV source. There are two LEDs up here at the top. There is the HDMI plus 5 volt, and there is the valid format LED. That's the one we want. Once it's connected, it's established as a valid connection, and that can be sent through. So what we want is to expose the valid format LED for both laptop 1 and laptop 2. And don't forget, we want to send these controls through our emulator so we can see them working on that UCI. So we have a connection for laptop 1, 2, that one for that, and then laptop 2 active 2 for the second laptop. Now, we got to figure out where we're sending this connection to. The first one is turning the TVs on. Well, if we head over to our user components, our Kolarchik TV user components, we already have the control pins set up for the power on and the power off.
That won't always be the case, of course. This user component was built in a very friendly way in which the power off and the power on control pins were exposed and the signal tags were even named for you. For a real device out there, you may have to, find those control pins and expose them or whatever it is you're going to need to control. That's what you would be wiring this to.
So we need a control function that can help us get those connections of the laptops to turn on the TV. I'll grab a control function, and in this case, it's either or, really. If one is connected, I want it to turn on, or if the other one is connected, I want it to turn on. So that means I'm using a logic or, and I've only got two inputs, and then I'll pull the input from our emulator, laptop 1 from, or laptop 2 from, and then power on. Perfect. So that means that now I have laptop 1, if it is connected, it's going to turn on the TV, or if laptop 2 is connected, that's going to turn on the TV. Now, what else are we doing with those connections of the laptops? We also want to make sure that when they're connected, not only is it turning the TV on, but it's also sending that to the displays. That laptop will then be visible for everyone. We'll get that from the actual input-output here. We have output 1 select HDMI 1. That would be the HDMI connection that is receiving laptop 1, and then HDMI 2. Now, I don't have the follow HDMI 1 selected for my second output, which means that I need this for both of the outputs. So now that I have those exposed, I'm just going to send from the emulator laptop 1 active from for output 1 select 1 and output 2 select 1. And then the same for the laptop 2 from the emulator.
Worth a reminder that in the real world, you could take these pins directly from the HDMI sources. We are just feeding them through our emulator script and back again, just so that you can see that in the emulator. So, don't freak out if you see that giant list of confusing signal tags. Don't let that give you any anxiety. That's just what we did to make this emulator work. Normally, you would just name them whatever you want them to name.
All right, so now we have all 4 of those set up. Now the laptops, when they're connected, will be sent directly to the displays.
And hey, Jacob, I'm going to jump in here. I did mine a little bit differently. I want to show you a couple different options that you may find useful. First thing that I did was I renamed the NV32H to have a really long name. And by doing so, that forces the width of the components to expand. And that way I can actually read all of my control pins. It drives me crazy when I'm looking at control pins and they all just say output select, and I don't know what number it is. So I gave it this long name of HDMI IO router selection so that I can literally read all of these. That's going to make it a lot easier for me to wire up and a lot easier for the next engineer who's looking at this to be able to understand what it is you're doing. The other thing I did was that I'm anticipating the possibility that, hey, there might be other things in the future in this design that might want the system to change to laptop 1 or laptop 2. If I just hardwire that signal name into the pin like Jacob did, then that means that's the only thing that can get wired to that pin. That's the only thing that can ever change that control. So what I did is I added a couple of logic ORs here, and I just named those logic ORs, changed to laptop 1 and changed to laptop 2. And I can expand these ORs as many times as I need to so that other things in the system in the future that might want me to also trigger this activity could now get funneled through this logic OR to have the same end result. So if you're thinking about things like that for the anticipation of future needs, you might want to use some of these control components in these kinds of ways to prepare yourself for the next time you need to come in here and edit it. It's ready for you. Back to Jake.
Okay, so we've got that part set up. Let's stick with our displays right now and figure out how we're going to turn them off. So the exercise said after 10 minutes, no activity, we want the TVs to automatically turn off. We're going to get that from the generic HDMI display components here. There is actually an inactive mode already kind of set up for us. Right here, the sleep mode is set, and after 10 minutes, it's going to turn that sleep state to on. So that's probably what we're going to want. Let's go ahead and expose that sleep state. If you select the component, head down to HDMI AV input. Near the bottom there, you'll see the sleep state pin.
Patrick sleeps with no clothes on, so his sleep state is always exposed. Jesus.
I don't think I needed to know that.
Why do you know that? Is it true? That's weirder now.
Okay, so we've exposed the sleep state. All we need to do here is send these to the power off of our 2 user components for the Kolarchik TVs. The way that I'm going to do this is I'm going to use another control function. I already have it here. I'll drag that in, and in this case, I am going to use a logic OR. If one TV or the other TV falls asleep, hits that sleep state, then I want those TVs to both turn off. So I'll set my input count to 2, and we want to make sure we're still running through the emulator. So right there at the top for me, I have TV 1 asleep 2, yes. And for that second one, TV 2 asleep 2, perfect. And then from the emulator, I will send to my logic OR TV asleep 1 from, or TV 2 asleep from, and then I'm just going to send that directly to the power off. So our displays now have some sort of control established over them. It's not necessarily something that the end users are pushing or intentionally doing, but it's almost automated. They're connecting their laptops, the TVs turn on. The TVs fall asleep at some point, and then they both turn off. Perfect.